Welcome to the study of alcohols. Now we start by distinguishing alcohols from what? Alkanes. First thing first, what are alcohols? Alcohols are a group of organic compounds that have the functional group hydrazine. In other words, OH. Now, whenever you see this functional group alcohol, remember that a functional group defines the what? The characteristics, physical, chemical properties of an organic compound. Now, whenever you see this functional group hydrazine, just know that they are alcohols. Just know that what? They are alcohols. Now, the way in which this OH is being attached to an organic compound determines the what? The type of organic compound that is being formed. For example, take a look at this. The manner in which this oxygen shares its electron with hydrogen or carbon determine the type of organic compounds that is being formed. If oxygen shares its two electrons with both carbon and oxygen, for example, what is the name of this? This is ethanol. When this oxygen shares its two electrons with both hydrogen and carbon, we will call this what? An alcohols. We call this an what? An alcohol. On the other hand, when this hydrogen shares its two electrons with what? The same carbon atom. With the same carbon atom, what do we call this? What do we call this? We call this what? A carbonyl compound. What am I trying to explain here? I am trying to tell you that the manner in which this oxygen shares its electron with what? Both carbon and hydrogen determine the what? The type of organic compounds that is being formed. All right, ladies and gentlemen, some students usually confuse alcohols with alkanes, which is the main topic for today. Now, what are alkanes? Some students will say alcohols are alkanes, but there is similarities between them having the what? OH functional group. But the difference is that when this OH functional group is attached to a saturated organic compound, we say they are what? Alkanes. In other words, I can also say that when this OH is attached to a carbon organic compound that is sp3 hybridized, I get an alkanes. I can also say this, that whenever this hydrazine is attached to what? A carbon to carbon single bond, I get what? An alkanol. When this hydrazine group is attached to an unsaturated organic compound such that the carbon to carbon bond possesses hybridization of sp2, of course, we know that alkanes possesses sp2 hybridization. Anybody that did first semester Chem 113, we know that alkenes, they possesses sp2 hybridization. What do I call this? I will call this an what? Alkenol. I just remove the E for their corresponding what? Alkene, and I replace it with what? Ol. On the other hand, when this OH is attached to a very, very unsaturated organic compound, such that the hybridization between the carbon atom is sp, of course, we know that alkynes are sp hybridized, and they are very, very unsaturated, and they have what? A triple bond. I will call this an what? An alkenol. What am I trying to say? I am trying to tell you that alcohols and alkanols, they are not the same. It is very, very interesting to note that all alkanols are alcohols, but not all alcohols are what? Alkanols. For the purpose of this lesson, especially those in University of Benin, I will refer this teaching to the study of what? Alkanols. Let us concentrate on what? Alkanols. What are alkanols? Remember that I said that when the OH is attached to what? A saturated what? Organic compound, we get what? An alkanols. Now take a look at this. Take a look at this. What is this? This is propanol. Prop, 3 carbon, and they are what? Single, then the OH, OL. Now, when you take a look at this, we discover that this carbon atom that is attached to what? This OH is being attached to another carbon atom. I will refer to all these ones as what? An alkyl group. In Chem 133 organic, we said that whenever an organic compound loses one hydrogen, we get what we call I. We get something we call like this. For example, when CH4 loses one hydrogen, it becomes CH3. What is this? This is methyl. When C2H6 loses one hydrogen, what is it called? We get C2H5. What is this? We call it what? Ethyl. So I will refer to this as what? An ethyl group. And this is the what? The hydroxyl group. Now it is very, very interesting to note that all these alkanols, they are what? They are similar to water in one way or the other. Both physical and what? Chemical properties. Take a look at this. This is what? An alkyl group. An alkyl group, OH. I hope you know that this is the same thing as this. This is the same thing as this. This is an what? An alkyl group, otherwise a methyl, attached to what? A hydroxyl group. I can also say that this is what? Similar to water in some ways. Look at water. Water is what? H2O. Water is what? H2O. If I remove one oxygen, if I remove one H, it becomes what? OH. If I remove one H, it becomes what? OH. Then another H has been replaced by what? An alkyl group. I want to use this as a reminder so that you remember the physical and chemical properties during the course of this exam. Because most questions you see is what? Solubility, chemical properties, physical properties, reactivity, and so on and so forth. So that whenever you remember the physical and chemical properties, for example, boiling point, melting point, you remember that of water, it will be very, very easy to remember what? That of what? Alkanols. So if this notion is acceptable, we can therefore say that the physical and chemical properties of alcohols, they are similar in respect to some ways to that of water. Let us continue. Classes of alkanols. Classes of alkanols. Now, we have 3 classes of alkanols. Depending on the what? The number of hydroxyl. Remember, the functional group defines the compound. The functional group defines the what? The compound. The classes depends on the number of what? Hydroxyl what? functional group present in the what? In the compound. In that notion, we have one. We have primary. We have secondary. We have what? Tertiary. We have what? Tertiary. How do we identify this? How do we identify this? Take a look at this. This is ethanol. Then I identify the functional group as what? OH, which makes me to what? Define this compound. Now, for me to know whether it is a primary, secondary, or what? Tertiary, I have to first of all look at how many carbon atoms that are attached to what? This very carbon atom that is what? Being attached directly to the what? Hydroxy. You have no business with what? This. But you have business with what? How many carbon atoms that are being attached to the main carbon atoms attached to the what? The hydroxy. If I use that notion, this is what? A primary alkanol. We have what? A primary alkanol. Why is it a primary alkanol? Because the hydroxy group, the carbon bearing the hydroxy group, is being attached to what? One carbon atom. Another example, take a look at this. Take a look at this. Take a look at this. This is a secondary. This is a what? A secondary alkanol. Why is it a secondary alkanol? Because it has been attached to a carbon atom that is attached to what? Another two carbon atom, which is what? This and this. Which is what? This and what? And this. The carbon atoms attached to the what? The main carbon atom in which the hydrogen is being attached to determines the what? The class of what? This what? Alkanol. I call this a secondary alkanol because the carbon bearing the hydroxy group will be attached to what? Another what? Two carbon atom. In other words, I can say this. I can say this is a tertiary what? Alkanol. This is a tertiary alkanol. Why is it a tertiary alkanol? Of course, we have already discussed it, that the carbon atom bearing the hydrogen group have been attached to what? Three carbon atom. Take it 1, 2, 3. They have been attached to what? Three what? Carbon atoms. Now, having said that, let us look at what? Types of what? Alkanols. Types of what? Alkanols. Types of what? Alkanols. Now we have the monohydric. We have the monohydric. We have the dihydric. Then we have the what? Polyhydric. Now, what are mono? We all know that anything mono is 1, anything di is 2, and anything poly is what? Is 3. Now, what are the types? Very simple. Whenever the alkanol is having one hydroxy functional group, we call it a monohydric what? Alkanol. For example, ethanol. This is ethanol. This is ethanol. This is what? A monohydric. Why is it a monohydric? It is bearing the what? One OH functional group. That is why it is what? A monohydric. What is dihydric? Two hydroxy functional group paired by what? An organic compound. For example, a glycol. For example, a glycol, a very popular Unibank question. Do not forget, a glycol is like this. This is a glycol. This is a glycol. What is the IUPAC nomenclature? This is what? It's a 1,2 diol. This is it a 1,2 what? Diol. You can also call it what? Glycol. Do not forget, glycol. This is what? A dihydric. This is a dihydric. How is it a dihydric? It is possessing what? Two hydroxy functional group attached to what? The same what? Compound. Two hydroxy functional group. Then what of polyhydric? Without explaining it, we know what polyhydric is. Poly means many. Poly means many. For example, glycerol. Glycerol is another popular Unibank question. Glycerol. 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 Propal 1,2,3 what? Triol is the IUPAC name of what? This compound. It is also called what? Glycerol. This is a polyhydric what? Alkanol. Now at this junction, let us look at what? Some common logics in what? Chem 124 as the subject what may be. Now, they might ask me a simple question. Since this is a polyhydric alkanol, is it proper for me to call this a polyol? Yes, I am very correct. I can call this a polyol. I can call this a polyol. Why do I call it a polyol? It is a polyhydric what? Alkanol. I can call this a diol. I can call this a diol. Yes, I am correct. I can call this a monool. Monool. Yes, I am very correct. Why? It is having what? One hydroxy functional group in that what? In that compound. Let us talk about names. How do we name this compound? How do we name this compound? Now, anybody listening to me right now will agree with me that organic chemistry, 65% of your examination comes from what's known as what? Nomenclature. 65% of your questions come from nomenclature. What's a nomenclature? The naming of this compound. How do we name this compound? What are the names given to them? We already started the words, a brick work on them already. How do we name them? Now, there are three ways to name what? Alkanols. There are three ways to name what? Alkanols. One, we have the carbinol. Carbinol system. Two, we have the trivial system. Then number three, we have the IUPAC system. Now, not being able to name an organic compound is like driving a car without a driver. You can't do organic chemistry without nomenclature. Now, today, we will talk about these three as a case study in our study of what? Alkanols. Let's talk about the carbinol. The carbinol. What are the carbinol notation? The carbinol notation assumes that all alkanols are what? Derivatives of what? Of the methanol. If I say they are derivatives of methanol, what do I mean? It simply means that the methanol itself is what? Is this carbinol. I will be correct to say that this CH3OH methanol is what? The carbonyl itself. This is the carbonyl itself because that's the rule. The rule says that what? All alcohols come from what? The derivatives of what? Methanols. Now, if I say this is this, for example, look at me. The manner in which this hydrogen is being substituted determines the name of what? This alcohol. The manner in which this what? Hydrogen is being what? Substituted. For example, look at this. For example, look at this. What is the name of this? This is methylcarbinol. This is methylcarbinol. This is methyl. This is the carbinol group. What is this? Are you not seeing that the difference between this and this is one hydrogen? Are you not also see that one hydrogen has been substituted for an alkyl group here? So we say that what? All alcohols are derivatives of what? Methanol. Then look at this also. Now look at this. Look at this. This is what? Propanol. The alpha name of this is what? Propanol. But I will call this ethylcarbinol. Ethylcarbinol. I will call this ethylcarbinol. Look at an ethyl group here. This is what? The carbinol group. Are you not seeing whether you name it from carbon 1 to carbon 20 or carbon 20 to carbon 100, this carbinol will also appear. Why? Because all of them are derivatives of what? Of methanol. And what are these methanol? This methanol is the carbinol itself. Is the what? The carbinol itself. So the manner in which the hydrogen in what? In the methanol is being substituted for an alkyl group determines the what? The name of what? That compound according to what? The carbinol system. Now look at this is an ethyl group. Of course, two carbon atom is called what? An ethyl. Then we have the what? The methane group, also known as what? The carbinol. That's it for carbinol. Alright, let's do another one. We have the CH3, CH2. Okay, let's do something like this. 2 what? CH OH. Now this is where some students get it wrong. If you look at this compound very well, somebody will refer to this as an ethyl group. Somebody will refer to this as what? As an ethyl group. And that's not the only thing. Some students are very funny enough to call this a what? A methyl group just because they see CH3. I said when a methane loses one hydrogen, you call it a methyl. It will be CH3. But you are seeing what? 3. You are seeing 3 here. What does this mean? Which means that what? We have 3 atoms of what? This methyl group. 3 atoms of what? Methyl group. That's the meaning of these 3. If I times 3, 3 times 3 will be 9. That's C3H9. This is this. But some students call this a methyl group. This is not a methyl group. I want to draw this out to show you something. I want to draw this out. I want to draw this out. CH3. CH3, CH3. So this CH3 is what? 1, 2, 3. That is why I put 3 here. Then this carbon atom is this. Then the what? The OH. What is the name of this according to carbonyl? This is what? Carbonyl system. I can also do it like this. This is the carbonyl system. Then what is this? This is how I name it. I will name 1, 2, 3. It will now be propyl carbonyl. Propyl what? Carbonyl. Propyl what? Carbonyl. Don't ever make the mistake of counting this carbon that is attached to what? Hydroxy in the carbonyl system. This is the carbonyl itself. So the carbonyl functional group must show in the name with respect to what? That compound. So that is that. Let's go to trivial name. 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 What is the trivial name? The trivial name are always the what? The derivatives. Trivial names are always the what? Derivatives. Look at this example. Look at this example. This is ethyl. Ethyl alcohol. This is ethyl alcohol. This one is the ethyl group. This is the what? Alcohol group. So it is, I could have called this an ethane. I hope you know. I will call this an ethane, but it is no longer ethane because one of the hydrogen atoms that is supposed to be here has been substituted by what? A hydroxyl group. So I will call this an ethyl because I told us that when an organic compound loses one hydrogen, we refer to it as what? An I. We refer to it as what? An I. So I will call it ethyl alcohol. Let's take a look at this. What is the name of this? Of course, we know already. This is what? Propyl alcohol. Propyl what? Alcohol. Then what about this? What about this? 1, 2, 3, 4, 5. What about this? This is pentyl what? Alcohol. Pentyl alcohol. Pent is what? Is 5. Pent. Pent 5 alcohol. Alright, pent alcohol. Pent I. Pentyl alcohol. Alright, that is it. Always try to what? Bring the alcohol out in the what? Trivial system. This is what? Propyl alcohol, ethyl alcohol. Why is it like that? A hydrogen atom has been substituted for what? A functional group which defines this compound as what? An alcohol. Alright. This comes to the what? The end of the video. We talked about the carbonyl. We talked about the what? The trivial names. Then in our next class, we'll be talking about the IUPAC. And the IUPAC system, we'll be talking about the what? The reactions, most importantly, reactions, as well as what? Their chemical. Their chemical what? Properties. So do not miss this class. It's going to be an unveiling. So stay tuned with Austin Achievers. Thank you.